So for question 51, we're asked to find the concentration of lead in solution, and they give us a bunch of extra information that we don't need. They tell us, right, when we add 5 grams of lead 2 iodide to solution in 500 milliliters of 0.1 molar calcium iodide. So they throw out a bunch of information and they make you think, oh, we're going to have to use all of this information. When the KSP for lead iodide is 1.4 times 10 to the minus 8. So really this question is just like the last question that we did. It's a common ion effect question. Yes, they gave you mass. Yes, they gave you this volume. Irrelevant. We don't need that to answer the question, because all that we need is lead 2 iodide is a solid. It's going to ionize to give us lead 2 plus aqueous and 2 iodides aqueous. The only difference here is we've added this common ion. I've added this common ion of calcium iodide. So when calcium iodide ionizes, that's a strong electrolyte. I'm going to get calcium 2 plus and 2 iodine in solution. And so because of that, when I go and set up my ice table, now my concentration of iodine is 0.2. It's 0.2 because when the calcium iodide ionizes, I get twice the amount of iodine. That leaves X as my lead concentration. So now I can set up my KSP, right? KSP equals the concentration of lead times the concentration of iodine squared. KSP 1.4 times 10 to the minus 8. Lead is my unknown. I don't know that. And iodine is 0.2 squared. So 1.4 times 10 to the minus 8 equals X times 0.04. Divide both sides by 0.04. And that one I can't do in my head, but 1.4 times 10 to the minus 8. I get X equals 3.5 times 10 to the minus 7 molar. So my concentration of lead in solution, right, would be 3.5 times 10 to the minus 7 molar. Again, they just gave us a bunch of extra information we didn't need, right? We didn't need to know how much lead they tried to add, because we can just find out how much lead can actually go into solution. We don't really need the volume here, but we did need to know concentration of my strong electrolyte and then how to use those, right? That subscript 2 tells us, well, it's going to be twice the concentration of iodine. Yeah, I can explain that too again, because let me just write it out one more time here. Right, the calcium iodide, when we add that to solution, we're going to get 1 calcium and 2 iodides. So when I put in 0.1 molar here and this ionizes, it's going to get 0.1 molar calcium. But because of stoichiometry, right, for every 1 calcium iodide that goes into solution, 2 iodine are generated. So because of stoichiometry, if 0.1 molar goes into solution, I'm going to have 0.1 molar calcium and 0.2 molar iodine because of that. Because for every 1 calcium iodide that breaks down, it's going to give us 2 separate iodines. So twice the concentration of iodine. And that's why I can plug in the 0.2 there, because the stoichiometry of the calcium iodide tells us that.